My presentation is on text summarization using the relationship structure of a document. And in this investigation, the concept of a document's relationship structure is used for automating summaries of documents. In this presentation, a new automated approach to analyze, understand, and summarize knowledge in documents will be explained. We'll also consider how to validate the correctness of an artificial intelligence algorithm. A background is going to be provided to justify the approach taken through a review of a long train of scholars. And these scholars explored the nature of language and its use in defining the boundaries of human knowledge. It looks at a document as a creative project in which the author organizes his discussion using certain relationship words. And after we've developed a text summarizer or any AI software, we need to validate it, which requires a different approach with AI than it does with traditional software systems. So artificial intelligence is the replication of human analytic ability. One of the main domains of AI is natural language processing, NLP. And NLP enables intelligent systems to both understand and generate human language. NLP has applied rule-based methods, statistical methods, machine learning, and deep learning to perform its tasks that we see here. The seminal work using modern computers for text summarization was by Hans-Peter Loon, who was a researcher at IBM. In a 1958 article in the IBM journal, Loon describes and justifies an algorithm to facilitate quick and accurate identification of the topic of published papers. Ramon Lull was a 13th century theologian and philosopher who developed a machine to make deductions that he believed would produce knowledge. Lull's contribution was in relating different concepts by the use of a thinking machine. One of his followers was Gottfried Leibniz. Leibniz followed up Lull's work with an alphabet for human thought and a syntax for combinations. The statistician Karl Pearson, in his work The Grammar of Science, argued that the obscurities in modern science are the result of an anemic orthology. And orthology means the accurate use of language. Ogden, a prominent linguist in the 20th century, took up this orthology challenge and developed a panopticon algorithm to generate orthologically correct sentences. Ogden's panopticon is a derivative of Lull's wheels of combination, but while Lull used his device to make syllogisms, Ogden looked to make unambiguous sentences. Krovitz called Ogden's panopticon a heuropticon because it generates concrete examples of an abstract concept in order to aid discovery, and this is a heuristic approach. Using his approach, one could combine concepts into meaningful sentences. The idea of recombining concepts as the basis for innovation and cultural advance was proposed by the anthropologist Homer Barnett. With recombination, the qualities of two objects that are similar but compared differently on some desirable performance trait are recombined. The weaker performer adapts the desired quality from the better performer. Wallace, a Canadian anthropologist, gave an example of how this combination approach was used in American submarine design during the Cold War. Sharks with a shark shape are fast underwater, while submarines with a ship shape are slow underwater. So, Try designing submarines with a shark shape. Krovitz developed his own panopticon algorithm that he called the relational algorithm. He created a set of words from Ogden's word sets that he termed relationship words. The idea is that a statement can contain a relationship between one concept and another if they're connected by one of the relationship words. In the 1971 proceedings from the Conference on Artificial Intelligence, Freeman and Newell considered this approach from an artificial intelligence perspective. They extended recombination to include not only new features to be added and existing features to be removed, but also what features that are existing should be increased or decreased. A document is a creative work that interconnects concepts in order to develop and present the ideas posed by the author. A line of thought for the past 700 years has explored different systems that connect concepts to create new ideas or reasoning that leads to discovery. We can look for such structures in a document in an automated manner as a method for natural language processing. Extractive text summarizers work by selecting what they consider to be the most representative sentences in the document and use them as the summary. The approach to text summarization taken by me is to rank the sentences based on their relationship interlocking, their employment of the basic relationship words to associate concepts that are used to develop the author's argument. The goal for such a summarization is to provide key concepts of a document in a few sentences. Another type of summarization is abstractive summarization, and that composes a summary rather than selecting representative sentences. A principal advantage of abstractive summarization is the cohesion of the paraphrase summary rather than the disjointed nature of extractive summaries. Generally, extractive summarizers perform better than abstractive summarizers. Extractive summarizers need fewer resources and they provide greater accuracy. The summarizer developed in my research is an extractive summarizer. So, software systems started in areas that had well-defined formal notations, such as the mathematics of engineering calculation or the mathematics of accounting systems. Software systems are now being applied to newer areas where the problems are not as well defined, the domains are highly dynamic, and there may be no clear correct or incorrect results. Many AI systems will change behavior when new information is ingested, including during tests. Furthermore, in many cases, AI systems are trained on data rather than based on a formal specification that defines the required operation of the system. Traditional verification and validation assumes the outcome is known in advance. This is difficult with dynamic systems such as our artificial intelligence that can change during testing. Moreover, for artificial intelligence, the modular design representations of the system often include black boxes, and it is not intuitively obvious what processing is done in the black box and how it is related to the domain problem being addressed. Validation is difficult in AI. Who is to say that one particular summary is correct, as even different people will produce different summaries? For text summarization algorithms, an automated tool for evaluating them that addresses these issues is available. Rouge is a tool that calculates the recall, precision, and F measure of a generated summary compared to a reference summary. Recall is the proportion of words in the reference summary that are also in the candidate summary, and precision is the proportion of words in the candidate summary that are also in the reference summary. F measure is a composite of the recall and precision factors. The methodology used is I take summaries from a standard text summarizer that is already published in R and a summarizer based on the relationship word structure of a document that I developed, and they'll both be compared to reference summaries using Rouge. A set of Rouge performance metrics for the two is then analyzed to determine if there's a significant difference between them in terms of their F measure. If they have similar Rouge scores, so that there's no statistical difference in the Rouge scores, then the proposed relationship word summarizer is considered validated. LexRanker is a standard text summarizer that is available in the R language. The relationship word summarizer was developed by me to extract summaries based on the number of relationship words in a sentence. An article about smoking in Appalachia was selected as the document to be summarized. The prepared article text was submitted to 7 online text summarization services. Each of these summaries became a reference summary used by Rouge to compare the summary generated by LexRanker as well as the summary generated by the relationship word summarizer. If LexRanker scored significantly higher than my relationship word summarizer, then we'd reject the null hypothesis that the relationship word summarizer has comparable performance to an existing widely used summarizer. Although the t-test is often used to determine the differences between such groups of scores, the t-test assumes that the distributions are bell-shaped. I could not find a study to confirm this assumption, so a Kolmogorov-Smirnov test, a KS test, was used to determine if the two sets of scores were different. Experts on the Rouge test recommend using the F measure score to determine the similarity between summaries. The results of generating the 2 candidate summaries, 8 reference summaries, and calculating the Rouge scores comparing each candidate summary against all 8 reference summaries are shown in this table. Higher scores denote better performance. At first glance, the widely distributed LexRanker and the proposed relationship word summarizer have similar performance across all 3 metrics. As noted, the F measure score will be used for further analysis. A visual comparison of the F measure for LexRanker and the relationship word summarizer is shown in this figure. The plot shows that the 2 summarizers appear to have similar performance with slight differences. The KS test on the F measure scores of the 2 candidate summaries resulted in a D statistic of 0.5 and a p-value of 0.2827. Since the p-value is greater than 0.05, we cannot reject the null. And the null is that the 2 sets of F measures are similar enough to have come from the same population. The results show that the Kolmogorov-Smirnov test found no statistically significant performance difference between LexRanker and the relationship word summarizer. So, in summary, relationship words associate the concepts in a document together to form a line of reasoning. The proposition of this research is that one application area for such a relationship word analysis is text summarization. A straightforward application program in the R programming language implemented this idea and was used to produce a test summary. An approach was also developed for evaluating the performance of the new text summarizer. It utilized the Rouge scores for the relationship summarizer against a manually prepared summary, as well as against 7 summaries generated by online services, and compared them uh, uh, with Lex Rankar's scores against the same reference summaries. The result is that the two summarizers, Lex Rankar and the relationship word summarizer, performed similarly, so there was no statistical difference in their performance. The major contribution to the field of artificial intelligence by this study is that it takes an alternative approach to natural language processing that is based on the relationship structure of a document. Historically, such an approach has been applied in the areas of linguistics and scientific inquiry, but it has not been implemented on modern computer systems. Although the approach in this study was applied to extractive summarization, analyses on other text summarization can be automated, and I'll be investigating these in future work. Thank you.